Hello guys, welcome back to CFD College. I'm Ashkan and this is tutorial 9 of Fluid Mechanics 1. In this video, we're going to solve 3 problems about dimensional analysis. As I said, it's tutorial 9 of this course, and before starting this video, please subscribe the channel and share these videos with your friends if you find them useful, and don't forget to like them. And if you have any comment or question, you can write your question in the comment section and I will answer you. Okay, let's jump to the first one. Tutorial 9. First problem number 13 of chapter 7. A thin elastic wire is placed between rigid supports. So we have 2 supports and we have a thin elastic wire. Fluid flows past the wire, and it is desired to study the static deflection delta at the center of the wire due to the fluid drag. So this would be the wire. Here we have this fluid flow and we want to think it's not good. Yeah, it's better. So if this is the wire, this should be the delta, the deflection at the center of the wire, and we wanna study it. We should consider delta is a function of L, length of the wire, D, wire diameter, rho, fluid density, mu, fluid viscosity, V, fluid velocity, and E, the modulus of elasticity, the Young modulus of the wire. Develop a suitable set of pi terms for this problem. So we should find dimensionless groups for this problem. First, let's talk about dimensional analysis. We use this to find and to develop dimensionless numbers. We use them in our studies, in our research, both numerically and experimentally. This way we can compare our results with results from other works conducted by other researchers. But how we should deal with these problems? First, if you follow some steps, it's easy. It's actually super easy. It's the easiest part of this course. So first step, make a list of the variables and their units. So first one is delta, second one is L, and go this way. 4 is rho, 5, 6, 7. So we have 7 variables, 7 parameters. Actually, we call these 7 parameters that we have or dimensional quantities. So we call these parameters and variables dimensional quantities. So And now we should write down their units. As you know, we have some fundamental units. For example, for length is L. For velocity, for time is T. For velocity is length over time. What else do we have? For force, we have F. So you can make a list of various things. For example, here in this problem, delta is length, so the unit is L. L also is length. D is diameter. Rho is density. The unit is Ft2 over L4. And viscosity is Ft over L2. Velocity is L over T, and Young modulus is F over L2. So as you can see here, we have different units. Let me write down here. So for force, we have F. For length, we have L. For time, we have T. And so velocity, unit for the velocity, unit is L over T. Density, for density, the unit is T2 over L to the power 4. Viscosity, is Ft over L square. What else do we have? Pressure, F force over area, so F over L square. And surface tension, it's F over L. And I think that's it. Yes, you can solve, I think, problems with these, and you can also realize that for Young modulus it's F over L2. Okay, so this is the first step. How many parameters? How many parameters do we have here? Actually, dimensional quantities do we have? 1 to 7. So we have 7 quantities. So M, which represents the number of quantities, is equal to 7. Then you should look for different fundamental units that are available. So we have L, we have F, we have T, L, F, T, L, F, L, T, L. Okay, so we have 3 different fundamental units. So N is 3. So by having M and N, number of quantities and number of different fundamental units, you can find out, you can calculate the number of dimensionless groups. So M minus N, which is 4 here, shows us the number of dimensionless groups. So we have pi 1, pi 2, pi 3, and pi 4. We have 4 different dimensionless groups in this problem. Now, the next step is to pick free variables. Why free? Because n is free, so you have to find n, and then you have to pick free, for example, in this problem, dimensional quantities. For example, and you know that they must include all of these units, I mean F, T, and L. You can't pick delta, L, and D. That's obvious, because that way you only have length in the units. The next rule is you never pick the first one. Why? Because the first one is the variable we want to study, so you shouldn't choose this one. So you have 6 other options and you have to pick them. For example, we can pick D for L, and then velocity V for T. We had L already, and now we pick V to have access to time, and then, for example, E for F. Now we have 3 quantities which include all these units. So now the last step, we should find pi 1, pi 2, pi 3, and pi 4 using these quantities. So we picked D. D is gone. V and E. Okay. Delta, L, rho, and viscosity. We start from delta. So pi 1 equals, we should start from delta, and here you should write the unit, which is length. In the denominator, we have to pick one of these 3 quantities we picked to get this unit, to have this unit in the denominator. So now in this problem, it's easy. D has the unit of length, so if I want length here, I can easily put D in the denominator. So the first one now is determined. Pi 1 equals delta over D. Let's go to the second one. Pi 2 equals, now delta is gone. The next one is L. L, and here the unit is length. It's similar to the previous one. If you want length here, it's easy to put D, diameter of the wire, here. So now we have the second dimensionless group. The third one, so L is gone, is rho. Rho, and the unit is ft square L to the power 4. It's a bit challenging. We start from F because F is only in E. So to cancel this F, I need another force here. So F over L2 should be here. it means that we should have E in the denominator. Now this F is gone. We have L2 here and T2. So let's deal with T square. T is in velocity. So actually we need T square since we have length in velocity. So if we have T2, we should have L2 in the denominator, something like this, and this is velocity. Actually this is L over T to the power 2 means V, sorry, to the power of minus 2, it means V to the power of minus 2. So I should put V to the power of minus 2 here. Now let's see, we have t square, and we have L to the power 4, so these are cancelled. So basically we have found our third dimensionless group, which is rho V square over E. Okay, rho is gone. The last one is mu. Let's write it here. Pi 4 equals mu, and here we have the units. The unit for mu is Ft over L square. So we start with F. So F over L square means we need E here. And now F is gone. We have to deal with T. So to cancel that T, I need T over L here, which means V to the power of minus 1. So here we have V to the power of minus 1. Now this T is gone, and we have L free, L to the power 3. Here we have L2. So if I multiply the denominator by L, now we have L2 and L2. So I need D here. So the fourth one is mu V over E D. Now we have all dimensionless groups, but the final answer, and many students forget to write down the final answer. The final answer to these questions is that you have to find something like this. Pi 1 equals function of pi 2 to pi m minus n. So the final answer to this problem is pi 1, which is delta over d, equal to the function of pi 2 L over d, pi 3 rho V2 over E, and pi 4 mu V over E D. This is the final answer. Don't forget that. Now let's solve the second one. Problem number 14. Because of surface tension, it is possible with care to support an object heavier than water on the water surface. The maximum thickness H, this is H, of a square of material that can be supported is assumed to be a function of, so H is a function of length length of the side of the square, density of the material, acceleration of gravity, and the surface tension of the liquid. Develop a suitable set of dimensionless parameters for this problem. Okay, so now you know how to deal with problems. First step. The first step was to make a list. The first quantity is h, obviously, the quantity that we want to study. Length is L. Unit is L. The second one, L. The unit is L. The third one, rho, f t square over L to the power 4. The fourth one, gravity. As you know, gravity unit is meters per second square. So it's length per t square. And the last one is surface tension. I told you that the unit is force per length. Remember that surface tension is acting everywhere, is acting on the circumference, not the area. Okay, 1, 2, 3, 4, 5. We have 5 quantities. M is 5. L 1, F 2, T is 3, and that's it. So we have 3 units, fundamental units. N is 3, so M minus N, the number of dimensionless groups, is 2. So we only have pi 1 and pi 2. N is 3, so we need to pick 3 quantities, except the first one, which is under investigation. So we pick L for length, gravity for T, and rho for F. So L, rho, and G are gone. We should start from H. So pi 1 equals, here we have H. The unit is length. It's easy to deal with. You know, we need L here, length, and we have L with the unit of length. So as you can see, this is the first dimensionless group. Pi 2 equals, so H is gone, and we have sigma. Sigma, the unit for sigma is F over L. So first we should cancel F t square over L to the power 4. So we need rho here. Now we have T2, T square, we should cancel it. So L over T, actually gravity has this unit, L over T square. So it's G. Now what do we have? F is gone, T2 is gone. We should have L length in the denominator. Now we need L square. Yes. Okay, it means that we need L square here. So we have pi 1 and pi 2. Don't forget, the final answer is pi 1 equals a function of pi 2 or 3 or 4 if you had them, sigma over rho GL square. So this is the final answer. This was really easy. Let's jump to the last problem, problem number 17. The pressure drop delta P along a straight pipe of diameter D has been experimentally studied. And it is observed that for laminar flow of a given fluid and pipe, the pressure drop varies directly with the distance L between pressure taps. So we know that delta P varies directly with the distance. It means that it has a linear function. It has a linear relationship with L. So delta P, I show it this way, has a direct linear relationship with L, or we can say delta P equals to, for example, C1 L. C1 is a constant number because the relationship should be linear and directly. Okay, assume that delta P is a function of, so delta P is function of diameter D and length with the velocity and viscosity. Use the dimensional analysis to deduct how the pressure drop varies with pipe diameter. Okay, we should find the relationship between pressure drop and the pipe diameter. We should find this. So to do that, we need to know, we need to have the dimensionless groups. So the first step is to make a list. We have delta P and 4 other parameters, so we have 5 quantitative parameters: delta P, D, L, V, mu. So the units, pressure is F over L square, force over area. D, for D is L, for L is L, for velocity is L per time, and for viscosity is Ft over L square. So we have 5 quantitative parameters. M is 5. We have F, L, and T. N is 3. So M minus N equals 2. We only have pi 1 and pi 2, 2 dimensionless groups. N is 3. We should pick 3 variables. D for L, for example, it doesn't matter which parameters you pick. The final answer is the same, so don't worry about it. D for L, V for T, and viscosity for F. As you know, we never pick delta P. If you pick it, you can find the final answer, but I recommend you never pick the first parameter. Okay, now let's find pi 1 and pi 2. Pi 1 equals, we should start from delta P because D, V, and mu are gone. Delta P, the unit is F over L square. So first we need to deal with F, so we should put mu here, F T over L2. So now F is gone and also this L square. But we have T here. We should cancel this, we should remove it in some way, and you know that we need to use velocity. The velocity has the unit of L over T, so if I put it here, velocity, and now this T is gone, but we have L here, so we need to cancel this. If I had this one, if I put 1 over L, everything is cancelled, and it means d to the power minus 1. Actually, it's L minus 1. So d to the power minus 1. So pi 1 equals delta p d over mu v. Now pi 2, delta p is gone. The only remain one is L. And L is easy because the unit is length. We need length here, means that we should pick D. Should put D here. So the final answer, never forget that, delta P times D over mu V is a function of L over D. Okay, now we have this relationship, and we know something. We know that the relationship between delta P and L is linear. Actually, delta P equals C1 times L. Here we have delta P, and here we have L. So we know that this function is a linear function. It should be a constant number. In that way, we will have dp times d over mu v equals C1 L, or C2, let's say, L over D. So let's put, let's take this diameter to the right hand side. So dp over mu v equals C2 L over D square. And from this you can see that the relationship between delta P and D is like this. Delta P and 1 over D square for a given velocity. So it has a reverse relationship, and with D square, actually, not D. So this, now we have solved 3 problems. It's not difficult, I think, and you can solve these problems. As I mentioned, this chapter is the easiest chapter of this course, and I hope you enjoyed it. If so, please subscribe the channel, share these videos with your friends anywhere they are studying fluid mechanics. These videos can be useful for them. And thanks for watching this video. Until the next video, bye bye.